Okay, welcome to section 1.2 of AQA A-level physics. Remember, this is applicable to all exam boards, so if you're Edexcel, OCR, any of the others, don't worry, there will be useful information in this video. So let's talk about the strong nuclear force, okay? So we've got the strong nuclear force. Okay, now force, we'll just call it F for now. Okay, now let's consider an atom, okay? In fact, let's go even closer and let's consider the nucleus of the atom. So let's say we've got many protons, many neutrons, all in about, okay? So we've got a pretty dense thing here, so we'll make it carbon, okay? So we've got a nice carbon atom. This is carbon 12. Okay, so we got a carbon 12 nucleus. Now, you know from your GCSE that positives repel. You bring two things together, they will go off in different directions. It's like if you bring a north pole of a magnet towards a north pole of a magnet, they will go away. So the question is really, why doesn't this happen inside our nucleus? So why don't these two protons fire off in different directions, okay? And the reason, which you've probably guessed, is this thing called the strong nuclear force, okay? The strong nuclear force. And this basically holds atoms together because really what we want is a nuclei that won't disintegrate, okay? So what it does is actually it overcomes this electrostatic repulsion. Okay, so you need to know that it overcomes the electrostatic repulsion. Okay, that is an important sentence for you to know, that it overcomes that. Okay, and that's very important. So it basically holds the nucleus together. So it's got a range, okay? Now the range is something you need to know off by heart. It's a very easy 6 marker, being like explain the strong nuclear force. So you will get already a mark for this. You can get a mark for its range is in between 3 to 4 femtometers, okay? Now a femtometer is very, very small, okay? So 1 femtometer is 10 times 10 to the power of minus 15 meters, okay? That is very, very small. It's about this, the range is about the same as the diameter of a small nucleus, okay? And it has the same effect between 2 protons as it does between 2 neutrons, okay? So same effect between, there we go, 2 protons and 2 neutrons, okay? So this is important. So it also keeps neutrons together as well, which are also being pushed into each other. Now, you'll always get marks for this diagram. This is a diagram you should know off by heart, okay? So we draw the axes like this, okay? Maybe actually don't draw this axis like this and this one like this, okay? This would be the appropriate way to do it. So first of all, we're going to draw the electrostatic force, okay? And that's like this. Now let's define the axes here. So we're going to have repel here above 0, and we're going to have attract, okay? And this one is obviously going to be distance, okay? So you know, the closer you bring 2 things together, the more repulsion they're going to get from the electrostatic force, okay? So you're the electrostatic. Okay, so now we're going to draw something called the strong nuclear force. So that goes down here, and then it comes up, and then very quickly it pretty much becomes 0, okay? So it's very important. Now you'd probably actually, it would be more like this if you drew it to scale, and this stays along 0 for duration, okay? And this is the strong nuclear force, okay? And this point distance can also be distance from center, but you know, distance is perfectly acceptable, okay? So we can consider maybe here, you know, you've got your center of the atom or whatever, but that's irrelevant really. Okay, so the attraction, maybe you would draw on the scales, you would draw here. So obviously it's between 3 to 4 femtometers, so that's the maximum range. So from here, you can have 4 femtometers. And sort of here, when it becomes attractive, so obviously there's a high repulsion bit which stops them going into each other. So this section here basically stops them merging. So basically it will stop this happening because we don't want 2 protons to merge into each other. Okay, and then when it becomes attractive, it's probably, I believe the figure AQA want is around half a femtometer. That may not be right. I think it's about half to 1.5. Okay, so you're probably safe with saying 1 femtometer. But it's important to label on the axes these 2 things, okay? So this is the strong nuclear force. It's very important to know it, okay? And it's a very easy 4 to 6 mark question for an exam. So I would definitely recommend you practice some of them. Okay, so I hope you guys found this useful, and in the next video we're going to look at radioactive decay.